Welcome to our webcast. Here we explore how the iTrace can improve your Toric IOL outcomes. The iTrace is a powerful tool for analyzing visual function and the source of aberrations, but it is equally powerful for cataract surgeons implanting premium and Toric IOLs. Another video in our series examines how one can achieve improved outcomes with premium IOLs by using the iTrace. The video explains the importance of optical alignment verification through the angle alpha value provided by the iTrace, and it looks at why the corneal optical quality should be evaluated with the iTrace to verify that the cornea will support the premium implant. In this video, we will focus on how the iTrace can help improve precision in Toric IOL surgery. Precision in Toric IOLs is the key to successful outcomes. Precision with calculating the axis of placement and the power, and then precision with achieving that axis in surgery. For every 1 degree misalignment, the patient loses 3% of the power of the lens. So a 10-degree misalignment will mean a loss of 30% of the correction. Precision is vital. Let's look at the tools available with the iTrace for Toric IOL surgeons. While doing the pre-surgical workup, we have placed our aligning marks at 0 and 180 degrees at the slit lamp, using a method that will be visible for surgery. The patient is then measured with the iTrace. With the Chang analysis and the angle kappa and angle alpha display, we have determined that our patient has a cornea clear of higher order aberrations, and the patient has a small angle alpha and is a good candidate for a Toric IOL. We move to the Toric Planner module and we're presented with a HOYA Toric calculator input screen. Here we enter the pre-surgical data. The patient has about a half a diopter of slightly irregular astigmatism as measured by the iTrace's Zernike wavefront fit analysis of the cornea. Notice that this is a different power and axis than what the keratometer might show as I click on the SIM-K button. Many doctors believe that this wavefront measurement of corneal sill is more accurate than the keratometer, especially when the sill is irregular. Now we'll enter the location of our planned incision and the astigmatism amount that we expect to induce with the incision. We'll select our pre-calculated IOL spherical power. The iTrace presents us with the various Toric lens options available from HOYA, which use the same power as Torics from other manufacturers. The presented options include an indication of the minimum residual astigmatism resulting from that lens option. Also note that you may choose to overcorrect this astigmatism if it gets the patient closer to plano and if this is desired. We click our lens choice and click OK. Here is the surgical plan display. We see the information from the calculator screen here. We see the calculated placement axis, and we see the highlighted lens we chose. Toward the center and right on the screen, we see the eye image captured during the corneal topography exam, and we see the reference ink marks. The iTrace also has a color image option, and if required, it would appear here. The axis of placement and the incision location are denoted on screen. Now let's assume that you are comfortable with adjusting your incision location. The iTrace will allow you to drag your incision location symbol and will display the adjusting residual astigmatism calculation in the panel on the right, so you can further neutralize the astigmatism with your incision. In this case, we are already at 0 diopters, so we'll leave the incision at 0 degrees. This also illustrates how important it is to be accurate when choosing your incision location and estimating your surgically induced astigmatism. So we have our placement axis as calculated at 89 degrees. We see the pre-surgical ink marks at 6 and 9 o'clock on the eye image. But the marks are not lining up to the 0 and 180 as we expected. How do we know where the 89-degree axis of placement is in relation to our marks? By using the Zaldivar caliper, as developed with the help of Dr. Roberto Zaldivar, we can adjust for the error in surgical mark placement and cyclotorsion and measure the arc angle from the marks to the axis of placement. One caliper end is anchored to the axis of placement. We move the other caliper end over the ink mark. The caliper tells us, in this case, the axis is 96 degrees superior nasal and 93 degrees inferior temporal, We use these values to set the surgical caliper in the OR, which will use the ink marks as a reference. Now with the error in ink marking and cyclotorsion zeroed out, we click Surgeon's View, which flips the display, and we take the printout to the operating room, or view it on a monitor there. We have our plan to precisely place and align the IOL. By using the combined HOYA iTrace toric calculator to accurately calculate the power and placement axis, and the result of our caliper to more precisely align the IOL axis, zeroing out the marking error, you can improve your outcomes and give the patient the premium vision that they expect.